Hello and welcome to today's class. Let's look at the concept of electric potential. So look at electric potential and its mathematical representation, right? So after that, we'll solve some questions based on electric potential and look at other derivations for the concept of electric potential, and then we'll solve several other past questions based on electric potential. So what is electric potential by definition? Electric potential at a point is the work done in moving a test charge from infinity to that point. Electric potential at a point is the work done in moving a test charge from infinity to that point. This is how you define electric potential. It is very important to note that electric potential is abbreviated using a symbol V. So V is a symbol for electric potential, while capital E is a symbol for electric field, or you call it electric field intensity. So I have V. V signifies electric potential, and then mathematically for electric potential, mathematically electric potential, that's V, is equal to KQ all over R. Alright, I have that formula there, KQ all over R. That's the formula for electric potential, that's V, and its SI unit is volt. Alright, volt is the S sign, that's V, is the S sign for representing electric potential. So electric potential is equal to KQ all over R. If you observe the last class, when we look at electric field intensity, the formula was E equal to KQ over R squared. In this case now, because of the KQ over R, so observe the difference between E and V. So E is electric field intensity, while V is electric potential. The formula is similar, it's just that the distance, one distance is squared and the other is not squared. So this one here has a distance not squared, that is R is not squared, but the other one that we did, that's capital E, which is electric intensity, has its own distance squared, right? So I have, so to get the video to our previous class on electric field intensity, you can just check this on this video, check the video description. I'll drop a link to the previous class that is called electric field intensity. If you want, you can visit my website and get the video, the full video on my website. All right, let's proceed, please. So I have the S sign as volt. So volt is simply the S sign for representing electric potential. All right, let's proceed, please. At this junction here, let's solve some example. Let's solve just one example. I'll look at other formulas for calculating electric potential. Example 1 says,
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen.
electric potential at a point M 15 meters from a charge 0.34 coulomb. So let's solve that question, please. It says, what is the electric potential? So solution. So your first start in science is that you list out the given parameters, please. So what is the electric potential? That's V. So V is unknown. We have to find V at a point M 15 meters from a charge 0.34 coulomb. My charge, that's my Q, is given as 0.34 coulomb. Please, we said when it comes to charges concept, Coulomb's law, and etc., try to draw a diagram. So in this case here, I have my diagram this way. I have a charge It says at a point M, 50 meters from a charge. So the charge here, here is point M. So my M is here and my charge is here. So from point M to this charge there, the distance given there is of course 15 meters. So 15 meters. So the R is given as 15 meters. So from here to here gives you 15 meters as my R. So I have, and Q is given as 0.34 coulomb. Alright, I have this diagram. So first things first, try to draw out diagram. So I have my diagram in this case. So let's proceed please. Let's proceed. Let's get the value of V. So we said V is of course KQ over R. So I have to recall. Let's recall the value of, let's recall the what we know. So let's recall. So recall. So recall that we said V that I have to look for is equal to KQ all over R. Let's get the value of V from here. V is equal to K is a constant, that's 9 times 10 to the power 9. Alright, that's K into Q. Q is of course 0.34. 0.34 coulomb. So all over R is my distance, and that's of course 15 meters. Of course 15. So V is equal to, if I punch my numerator together, if I punch numerator, 9 times 10 to the power of 9, right, multiplied by 0.34. I have the value as, the value is given by 306 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. All right, this becomes the value of numerator all over 15. So that gives V should be equal to, if I divide by 15, that gives around that gives me 204,123. Okay, 1 2 3 4 5 6. All right, this becomes my value for V. Of course, this answer is perhaps too long, so to shorten it, I just apply your indices concept standard form. So I can have 1 2 3 4 5 6, right? I have 7. That should give around, let's say, this can become 20.4 times 10 to the power of, we just moved 1 2 3 4 5 6 7, that's 10 to the power 7. So V can be expressed as 20.4 times the power 7, right? So as shown on the board this way. So you can leave your answer in this form, still correct. Also, you can leave your answer that V is equal to, this is 204. 204 times 10 to the power of, how many 0? 1, 2, 3, 4, 5, 6, 10 to the power 6. So this and this are still the same thing, and this still the same thing, right? So my answer should be in vote. Of course, we said 10 to the power 6 represents a prefix called mega. So I can say my answer should be 204 megavolt. Is still much more correct. Anyhow you want to put your answer, you are still correct. So let's proceed with other concepts in the study of electric potential. Let's do electric potential energy. So let's move to the next concept called electric potential energy. What's electric potential energy? By definition, electric potential energy is also called electrostatic potential energy. Please bear in mind, it's also called electrostatic potential energy, or you call it electric potential energy. By definition, this is the energy a charge has been virtual of its position in any electrostatic field. I said this is the energy a charge has by virtue of its position in any electrostatic field. It's important to note that electric potential energy is represented by UE or U, right? Either use U or E. Any of it is still much more correct. So let's just use E. So U is the symbol for representing electric potential energy, and mathematically, so this U, that's that electric potential energy, is equal to K Q1 Q2 all over R. So electrostatic potential energy or electric potential energy is given by KQ1 Q2 all over R, as you can see on the board. All right, please check something, please. Let's do a quick recap. We said that from the beginning, said force is equal to what? KQ1 Q2 all over R squared. This man is Coulomb's law. We now move to what we called electric field intensity, that's E. We said this one is equal to what? KQ all over R squared. We now move into what we called electric potential. Sorry, electric potential, that's V. So that this one is equal to KQ all over R. Now dive into electric potential energy, that's U. And so that's equal to what? KQ1 Q2 all over R. So observe the difference between this stuff here. So know how you assimilate them. Know when to use R squared and R. So this is how it works. So this is from Coulomb's law. This one is electric field intensity. This one is electric potential. This one is electric potential energy, as you can see on the board. This is like a summary to what I've done so far. Right. So let's proceed from here. So at this point here, it's important to note, please note something, one key concept. Note one key some concept. We'll proceed with solving past questions. So note one key concept, please. Note, please. Electric field intensity, electric field intensity and electric potential energy are related by the equation. I said electric field intensity, that's capital E, and electric potential energy, that is capital U, are equated by the equation E equal to V over R. E equal to V over R. So I can say that E can also be expressed. E can also be expressed as V is volts, R is distance, that's in meters. So that's why when I define electric intensity, I said it can be measured either in Newton per coulomb or volt per coulomb. This is how I got the value for volt per coulomb. I said I'll show you last class, right? Under electric field intensity, right? So it's also volt per coulomb. So this becomes your relationship between electric field intensity and electric potential right? So I have this one here. Let's take one past question and then see how it works, and then I'll proceed to next concept.
Alright, guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the 100 level student to have access to both. right? So once you once you join the general membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.
Two charges Q1 equal to 5 microcoulomb and Q2 equal to 4.3 microcoulomb are separated by a distance r equal to 150 millimeter. If a third charge Q3 equal to 2.7 microcoulomb is placed midway between Q1 and Q2, find the electrostatic potential energy, that is or you call it electric potential energy, or you call it electrostatic potential energy on Q3 due to the other charges. So it kind of says two charges Q1 and Q2. So I have two charges Q1 and Q2. So let's say Q1 is here. All right, Q1. I have Q2 are separated by distance. So distance from here to this point here is of course 150 millimeters. All right, it says if the third charge Q3 is placed midway is the center. So charge Q3, let's say charge Q3 is placed midway this way. All right, midway between Q1 and Q2. All right, find the electrostatic potential energy on Q3. So I'm asked to find the electric potential energy on charge Q3, right? So that becomes like more of like I'm asked to find U3. So that is electrostatic potential energy at charge Q3. We have to find the value for electric potential energy at charge Q3. So let's consider this. Okay, distance. So if here to here is 150, so I can say that from here to here, we have a distance here to this point here to have a distance. All right. So if here to here, so I should have 75 millimeters, 75 millimeters. All right. That's half of the distance this way. All right. So it says we should find, it's asked us to find the value for the electric potential energy or electric potential energy at charge Q3. So here's the concept is I'm going to find the sum. So to find the electric potential energy at charge Q3 is simply the ability for me to compare the electric potential energy at charge Q3 due to charge Q1. So here's the concept. To get the electrostatic potential energy at charge Q3 is simply the sum of the charge charge Q3 due to charge Q1 plus charge Q3 due to charge Q2. So it's simply the concept we have done last class. Like so I'm comparing charge Q3 to charge Q1, charge Q3 with what charge Q2. So I'm saying that U3, the U3 means electric potential energy or electrostatic potential energy at charge Q3 is equal to U13 plus U23. So I'm comparing 1 and 3 as this case, then plus plus 3 and 2 or 2 3 as in this case. All right, I have this place. So let's get U13, let's get U12. So let's get U13 first. Let's get U13. So U13 is equal to formula for U13. What's formula for U neutrally? U is what? KQ1 Q2 over R. So I shall have K, so Q1 as per the one here, then Q, this is 3, Q3 all over R 1 3 because I'm under 1 3, so the becomes r1 3. R1 3 means distance between r1 and r3. All right, I have this place. This is now equal to k is 9 times 10 to the power 9 into q1. So q1 is what? All right, so q1 so q1 so q1 is given by, so q1 is equal to 5 microcoulomb, q2 is equal to 4.3 microcoulomb, and q3 is equal to 2.7 microcoulomb. Well, I have the space. So q1 is of course 5 times 10 to the power minus 6 into q3, that's 2.7 times 10 to the power minus 6 all over r13, distance between rq1 and q3, that's this 75 meter. So if I have 75 millimeter, convert this one to meter, that becomes 0.007 meters. Similarly, so yeah, all right, I have this. So that becomes r13 gives you 0.007. All right, I have this place. I have this value here as 0.007. All right, from here, what do I get? So what's u13? So u13 should be equal in value to, if I punch calculator, I shall have 1.62. So that gives you 1.62. Please, what's the S sign for? What's the S sign for? I didn't give S sign. What's the sign for electric potential energy? See, since the word energy is there, so my S sign becomes Joule. S sign is Joule, right? S sign is Joule. So my S sign here becomes Joule because of the word energy. So that becomes Joule. All right. So U13 gives you 1.26 Joule. Let's get U23. So let's get U23. U23. So U23. So U23 is equal to K Q2 Q3 all over R1 R23. This is now equal to K is 9 times 10 to the power of 9 into Q2. So Q2 is of course 4.3. That gives 4.3 times 10 to the power of minus 6 into Q3 is of course 2.7 times 10 to the power of minus 6 all over R23. Distance between R2 and R3. R2, R3 becomes 75. That becomes 0.007. Alright. Let's get U23. So the value for U23, the value for U23, so the value for U23 should be equal to, so U23 should be equal to, if I put everything here together, U23 should give me about 1.39 joule. That becomes 1.39 joules, right? So let's get the electrostatic potential energy at charge Q3. That becomes U3 is equal to U13 becomes U13 plus U U23. This U3 is equal to U13, of course 1.62. 1.62 plus U23 of course 1.39. The electrostatic potential energy at charge Q3 will be equal to, if I sum this answer together, I shall have about 3.01 joules. So this becomes my answer, 3.01 1 joules. This is how you solve this particular question under electrostatic potential energy, or we call it electric potential energy.
Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.
See you in our next class. Do well to get my course, buy my courses on my website, or you can join my channel membership for the WAEC and JAM classes, or for the high level students to get access to exclusive videos on my channel. Once you join the membership, you have access to good and interesting science topics in the membership. So do what to join the channel membership. All right, see you guys in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,